So welcome everyone. This is 3.6 on rational functions. Rational functions just means that your x is being divided. Yeah, we're getting a ratio of of our x's. So the parent function will always be 1 over x when we're talking about basic rational function. Okay. Since my variable x is in the denominator, right? It's in the denominator of my second function. So when that happens, we need to understand asymptote. Okay, what is an asymptote? What's the definition of an asymptote? Anyone?
Usually like a line, which direction left goes,
Yeah,
and it can be on y and x.
yeah. So it's a line. Okay, in this case, it's a line that the graph or the function, I should say, cannot cross. Okay, we're gonna debunk that definition in our second um, lesson. But for now, it's a line that the function cannot cross. So it acts like a fence or a wall. Okay, so you guys can imagine it's a fence or a wall. Okay. So now that we have a general understanding of what an asymptote is, let's go back to our rational function. So in this case, when we're trying to build our asymptotes, we're just thinking where is our fence or our wall? We're always going to be thinking these two questions. What can't x be? And what can y be? Okay. So what can't x be? X cannot be zero, right? Because it's in my denominator, right? So x cannot be zero. What can't y be then? Zero. Yeah. So can you guys ever think of an x value I can plug into my rational function here? That'll make 1 over 0 or 1 over x equal to 0. You guys are trying, right? But there is no number. There's no number that I can plug in for x that'll make 1 over x equal to 0. Okay? So that's why we have two asymptotes. Y equals 0 is one of my asymptotes, and x equals 0 is the other asymptote. So there's two fences. Okay? Make sense? Yeah. Okay. So now we're going to head over to the parent function graph of it. So the key points here, and I'll put it here, but I want to put it up there. Key points for this. What's an easy number to remember? What can I plug in for x? That's really good. 1. 1. If I plug in 1 into here, 1 divided by 1 is 1. What's another number that's easy? -1. So -1, if I plug in -1, 1 divided by -1 is -1, right? So those are my key points. Okay? So I got my asymptotes at y equals 0 and x equals 0, which I'll do it with this highlighter so everybody can see it. So y equals 0 That is the horizontal line right here. And then x equals 0 is the vertical line right there. Okay, so I'm gonna back this out. Okay? So let's label those two lines. My vertical line will always be x equals whatever number that line is on. Okay? And my horizontal line will always be y equals whatever that line is on. All right? And I'm going to graph 1, comma 1, which is right here, and negative 1, comma 1, which is right here. And if you don't need these key points, but I'm going to show you this in the first one because I kind of want you guys to understand where the curve is, right, of this graph. So if I plug in x equals 2 into my function here, right, 1 over x, what would I get if I plug in 2? 1/2. So it's 2 comma 1/2. What if I plug in 3? 3 comma 1/3. Okay, so you can see that it's gonna kind of ride this y equals x asymptote, right? How about x equals 1/2? What would happen if x equals 1/2? If I plug in 1/2 into my function? 2. So 1/2 comma 2 is right here. What if I plug in 1/3? 3. So plug in 1/4, 4, right? So you can see that it kind of rides that line, right? So my function would go something like this. My curve, which is like surfing the two asymptotes. Okay? And vice versa, we can do this with the negative. And what if I plug in negative 2? What would I get? Into my function, negative 1/2. If I plug in 3, negative 1/3. If I plug in 4, negative 1/4. If I plug in 1/2, I get, or negative 1/2, I get negative 2. If I plug in negative 1/3, I get negative 3. Negative 1/4, I get, negative 1/4, I get 4, right? So also, you can also see that this kind of rides the function there. Okay, so this is my parent function. That's why 1 comma 1 and negative 1 comma 1 are the key points. Okay, but you can see that the graphs, the curve would be riding those two asymptotes. Okay, let's get my domain and range. What is my domain in interval notation? In interval notation, what is my domain? What's all possible x values?
Everything but 0.
Everything but 0, right? So if I put that in interval notation, it would be negative infinity, comma 0, union, 0, comma infinity. What about my range? It's the same. Same thing. Negative infinity to 0, union 0 to infinity. It's the same for both directions because we have our asymptotes at x equals 0 and y equals 0, right? And you can see that here it goes on forever. Oops. Okay, so here And here it goes on forever negatively, and here it goes up forever positively. And here it goes on forever negatively, and here it goes on forever positively. Okay, that's why it's everything besides zero. Cool? So that is our parent function. Questions on that? You got your key points, you got your asymptotes. Oh, this page doesn't even have your asymptotes, it's up there. So your asymptotes are at x equals 0 and y equals 0. Okay? And then the basic one, this one, right, the basic graph of a rational function, we are just going to use transformation, okay, to graph this. All right? So using transformations to graph this guy here, 2 equals, or graph 2 divided by x minus 3, we can rewrite this function to make it look like our parent function. Remember, our parent function is f of x equals 1 over x, right? Yeah. So can I factor out the 2? Can I pull out the 2? I can make it look like 2 times 1 over x minus 3. Right? Yeah. Now that's something I can work with my transformation. Now if you think about it, I have 2 transformations here. This 2 transforms my parent function, and this negative 3 would transform my parent function, correct? So let's talk about the 2 first. The 2 in my parent or my function here, what does that do to my graph? What transformation is that? How do we describe the transformation? It's a stretch. What kind? Vertical stretch. So it's going to be a vertical stretch. Remember this term, BAFO, by a factor of 2. Okay. Does a vertical stretch out the asymptotes as well? Or let's talk about our asymptotes first in terms of transformations. Okay. You guys see the y equals x in the, or y equals 0 and the x equals 0 line, right? When I stretch it, will that be affected? Will my asymptotes be affected with a stretch? 1 for yes, 2 for no, 3 for I don't know. Go. 1 for yes, 2 for no, 3 for I don't know. 1 for yes, 2 for no, 3 for I don't know. If you stretch a line, will it get thicker? No, right? A line is a line is a line is a line, right? Yeah. And it goes on forever. So even though you stretch it out, it won't do anything. So what is the transformation that would affect my asymptotes? Huh? Shift, right? If I literally pick up my asymptote, right, and I move it up or move it down, or in this case, x equals 0, the vertical asymptote, if I move it to the left and move it to the right. Those are the only things that would, those are the only transformations that would change my asymptote. Okay, so shifts and reflections don't. All right. Oh no, I'm sorry, not shifts. Stretches and reflections don't. Okay. Only shifts would affect my asymptote. Cool. Okay. So going back to this, now what I want to do is I want to change up my key points. So my key point, my parent key points, right, were -1, -1, and 1, 1. When I vertically stretch this by a factor of 2, what are my new key points? -1, -1 turns into what's the rule? You guys remember the rule? If I have a point x, y, if I vertically stretch it by a factor of 2, what happens? Well, you know, will my x change or my y change? It's vertical. My y, right? So my x would stay the same, comma, y would turn into 2y. So all I'm doing is multiplying my x value by my y value by 2. So my -1, -1 would be -1, -2. 1, 1 would turn into 1, 2. Questions on that? No, right? Simple. Correct? Okay. So now I can graph those 2 points. What about the -3 right there? What happens with the -3? What type of transformation is that? The -3. Go to the right 3. Shift to the right 3, right? Correct? Shift right 3 units. Okay? So let's talk about my asymptotes. Y equals 0. Would that change? Yes.
And it goes to the right.
Would y equals 0 change? Remember, that's my horizontal asymptote. Yeah. If I shift the horizontal line over to the right 3 units, still the same line, correct? Yeah. So that doesn't change. It's still y equals 0. How about x equals 0? Would that change my vertical asymptote? It would literally move 3 units to the right, correct? So that one would be x equals 3. Questions on that? No? So I got my asymptotes now at y equals 0 and y equals 3. Okay? Now let's shift my key point. Now, since I already stretched it out, I'm not going to go back to my parent function key point. Okay? So I'm going to use the -1, -2 and +1, +2 points to shift it over to the right 3 units. So what's the change in my key point? What's the rule here? X, y would turn into, with a shift over to the right 3 units, what would it be? X plus 3, y, correct? Because my y's don't change. It's just a shift up to the right 3 units. So -1 plus 3 is 2, -2. 1 plus 3 is 4, +2. So those are my final key points, right? I have my asymptotes. I have my key points. So now it's time to graph. Okay. Y equals 0 and y equals 3 is my asymptotes. So y equals 0 is right here. Oops. Sorry. Let me change up the line so it's dotted. And then we dot this line or we dash this line to signify it's an asymptote. And then y equals, or x equals 3 is my vertical asymptote. Okay. So that is x equals 3 and y equals 0. Okay. And then I'm going to plot those 2 points. 2 comma negative 2 is right here. And then 4 comma 2 is right there. And then what I'm going to do with the 2 graphs or the curves, I know the way it looks because we already did our parent function. I'm just going to do that. Yeah. Let it ride the 2 asymptotes. Cool. Yeah. So that's just a refresher on transformation. Okay. If there's a negative on the outside, you know it's a reflection. Yeah, so you just reflect the 2 curves. If we're multiplying on the inside, just pull it out. Make it into a vertical stretch instead of a horizontal compress. So what I'm saying is, if I have a function, I'm just going to talk about it because now I believe we are good. I have 2x, right? Like that. Yeah. Instead of thinking vertical or horizontal compress, I'm going to make this into 1/2 times 1 over x. Okay. So make it into a vertical compress instead of a horizontal stretch. Yeah. Okay. And then go from there. Cool. Okay, now I kind of want to preview the next step. You guys remember this statement here? Drea. Yeah. Well, Drea means we're going to get the domain, we're going to reduce, we're going to get the domain, we're going to reduce, intercepts, asymptotes, and holds. Okay. And here, in terms of the asymptotes and in terms of holds, there's a bunch of rules that we got to keep in mind. And it gets confusing if you're not focused. Yeah, even for me. All right. So after Thanksgiving break, we are going to get into this, and hopefully the Thanksgiving break will give you a new sense of, or new energy, so that I can use up all the energy with this lesson. Cool. That's the lesson for today, class. That was on 3.6, rational functions, the basic version. And I will see you on the next one. Bye.